For example 6, we're going to talk about a really important idea when we talk about graphs, whether it's in grade 10, 11, or 12. And it's the idea of writing a domain and a range. We're looking at permitted values. What counts in a graph and what doesn't. And you can do that for both the domain, which are the set of x's which run left to right, and the range values, which are our y values, and they run up and down. So you got to be really careful where you're looking for your set notation, whether it's domain or range. So let's have a look at this funny shaped graph here in part A, and we're going to do a list. We're going to do domain first and write our set notation, and then we're going to look at our range. So domain, remember, is the set of x values. So when I write my set notation, the set of x such that, we're going to figure out what values are included here. But because the graph is connected, all of our x values have to come from real numbers. Our data is continuous. So we can start out with that much. When we look at our domain, we're looking left to right. What numbers count? When our graph runs off like this, usually in our textbooks and when we draw on your work sample, we have arrows there, but for some reason your textbook just goes off the page, and that's meant to say this goes this way forever. So if I'm looking left to right at this red graph, I know that this graph has a definite starting point here, and then I could draw the graph, and it would continue this way through all the x-axis to my left to infinity forever. But when it's running to the right, my graph hits an endpoint right here. This endpoint happens when the x value is 3. That's the furthest value on the right, so that's going to be my highest value. My graph then starts here, and it runs this way forever. So all of the numbers in the domain, all of these x values start at 3 and they continue lower forever. So all of my values for x's will be less than, equal to, because we have a closed dot, 3. And x belongs to all the real numbers. All right, let's look at the range now. I'm going to move all this blue and red from the red so that you can see, and I'm going to choose to continue in green for my range. So my range, remember, are my set of y values. And because the data is continuous, the y values for my range are going to be real as well. So when I look now for my range, I'm looking up and down. So I'm looking along this y-axis. So this is the lowest place on the y-axis that my graph will go. That's -1. My graph will continue and continue to have values on the y-axis all the way to the top. And remember, this continues up forever. So this y-axis will have a value somewhere out here on that graph to infinity. So it goes up forever, but this graph goes down to the bottom at -1. So all of the y values that are going to make sense in this graph are from -1 and up. So my y values will be greater than or equal to -1. All right, those are tricky to do. Let's have a look at part B. Part B is another funny graph. We're going to do domain and range again. So for the domain, remember, we're looking only at the x values. What makes sense going left to right? My graph is connected, so it's going to be real numbers. So if I'm looking left to right, this is a boundary on the left, this is a boundary on the right. All of my x values make sense in between -2 to 2. So all of my x values will be in between -2 and 2. Because these are closed dots here, -2 is included, +2 is included. So lower, I'll use less thans and less thans, and included because the dot is solid on both of these endpoints. So my domain is the set of x such that all of the numbers in the list will be between -2 and 2, including both those values, and connected means it's all real numbers. So let's look at the range. Now remember, we're looking only on the y-axis, we're looking up and down. So on the range on the y-axis, this is the top of my graph. There's nothing in red that goes beyond y equals 2. We'll have points all the way down here, the y-axis, until I get to here. There's no points below 0. So my y-axis will have values that are trapped between 0 and 2. So in my range, it'll be the set of y such that 0 was the smallest value. It's included. There are points where y is equal to 0. The highest value is 2, and that's included on the graph. It's not an open dot. And because the graph is connected, y belongs to real numbers.